All right, boys and girls, let's keep doing some proofs. So we did side, side, side in a lot of the proofs. What about side, angle, side? We haven't done that one. So here is side, angle, side proofs. Okay, so draw this picture, and notice how nothing's marked. We're going to practice doing that. And here's the given, and here's the proof. So write all this down. Okay, cool. All right, so let's start our statements and reasons chart. Okay, so BA is congruent to DC. So BA is here, congruent to DC. And then I'm also going to write it here as given. Bam. Okay, what else does it say? Ooh, now it tells us an angle. Angle BAC is congruent to angle DCA. That's given. So BAC, so you just trace it. BAC, the middle letter is the vertex right there, is congruent to DCA. So DCA. DCA. So that's this right here. Okay. So those are the two things that are given. So now we have to prove, eyes on the prize always. ABC, this triangle here, is congruent to triangle CDA. So we have a side and an angle in both of these. So we have a side angle, so we need another side. So I'm looking at this, I need another side. Can I get another side? Yeah, by the reflexive property. Because AC is shared between these two. So now I have side, angle, side. Is the angle included? Yes. It's in the middle between the two congruent sides. Side, angle, side. Okay, so I can't forget to write this because I have one, this is side to myself, one angle. So I need another side proof statement. So that's going to be AC or CA is congruent to AC. Why? That is not given. That's the reflexive property. So I have side, I have angle, and then this is only going to give me another side. So now I have triangle ABC, side, angle, side, okay, and then CDA. CDA, this triangle, side, angle, side. Okay, so everything's proven. So now I drop the hammer, just copy it down. Triangle ABC is congruent to triangle CDA. Why? Side, angle, side. Postulate. There we go. And that's basically the same thing we did with side, 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 but now it just incorporates an angle. All right, let's try another one. Copy this down. Yeah. So this comes from like a hang glider here. So look at this, extreme sports right here. So see this hang glider? So both of his parts of the hang glider have to be congruent or else he's not going to be able to fly correctly. He may not get any lift. He may be in a lot of trouble. So we got to make sure that both sides are congruent of his hang glider. This is what we're given so far. FG is congruent to GF. Whoop. Sorry, GH, my bad, GH. So let's write our two-column proof. Statements and reasons. Our first thing, FG is congruent to GH. Given, bam. Okay, so now it has JG, so line JG, bisects angle FGH. Given. Why? Because it tells us it's given. Okay, so what do we have here? So look, odds on the prize. FGJ has to be congruent to HGJ right here. Okay, so these two triangles have to be congruent. What do we have? Well, what can we do with this? That's the first thing I asked myself. This doesn't give us a side, so we just have this side. This doesn't tell us anything about what's congruent yet because there's no congruent mark, right? So JG, this right here, bisects this angle. So FG GH. So this bisects. What's bisect mean? Yeah, cut into two equal pieces. See, bi, that means two. So like bicycle, two wheels. So that would mean that this angle is congruent to this angle. Because bisect means cut in half. So what do we just do? So we have two angles now that are congruent. So let's cite them. So angle FGJ is congruent to angle HGJ. Why? That's not given. How do we know? Because that's what a bisector is. A bisector cuts an angle or a line in half into two equal pieces. And equal means congruent. So this is going to be definition of bisector. Of a bisector over bisector. If you want to put A in there, that's cool. Definition of a bisector. All right, so this is another congruent, so this is an angle. So I have side angle. Can I get another side? Yeah. Oh, this keeps coming up. Good thing we're practicing it. That is a reflexive property congruent side, shared side like that. So I have angle, side, side, angle, side. Side, angle, side, and then we're locked in. So I just have to say my last piece about my reflexive property. And if you leave this out, it's going to be wrong. You have to have all the parts stated. Reflexive property. Notice how it's the same thing over and over again. The more you do these, the easier it's going to be for you. So side, angle, side. It's not part of the proof. Just a little note to myself. If I want to erase it at the end, you can. This is the important ish right here. So I have side, angle, side. Drop the hammer. We done. So triangle FGJ is congruent to triangle HGJ. Why? Side, angle, side. Postulate. Bam, got it. All right, good work.